In this video, let's discuss the step response of an LTI system. Let's consider two cases in that. The first case is show that the step response of an LTI system is running sum of impulse response. In second case, show that the step response of an LTI system is running integral of impulse response. Let me take the first case. We know that the discrete LTI system has input say x of n and output say y of n. Let h of n be the impulse response of the system. So in this case, the output y of n can be represented as y of n is equal to x of n h of n, that is convolution between x of n and h of n. Step response of LTI system means the response of the system when the input is step signal. That is, if input signal is unit step signal, that is, we can say here input is x of n, let x of n is unit step signal, that is u of n. Then output of the system is known as step response and is represented as let let s of n be the step response, that is response of the system for the step input. I can represent it as h of n, because here y of n is equal to x of n star h of n. It can also be represented as h of n or x of n because it follows commutative property. X of h of n star u of n, because we have considered x of n as step input signal u of n. So this can be represented as summation convolution between two signals is given by summation k equal to minus infinity to infinity h of k u of n minus k. We know that u of n minus k is equal to 1 for n minus k is greater than or equal to 1, or it can be represented as n is greater than or equal to k, or we can represent it as k is less than or equal to n. So considering this, I can represent s of n as s of n is equal to summation k varies from minus infinity to, that is k value should be less than or equal to n, that is here it is n because k value supposed to be less than or equal to n, h of k. Therefore here we can see that s of n, so here from this equation it is seen that step response of a discrete time LTI system is running sum of impulse responses. Here h of k represents impulse response. Therefore step response is step response of discrete time LTI system is running sum of impulse response. Now let me consider continuous time LTI system, that is case 2. Let a continuous Let a continuous time LTI system having impulse response h of t, the input is say x of t and output is y of t. We know that output y of t will be equal to x of t convolution with h of t, or it is also equal to h of t x of t. So here also let me consider the input signal as step signal. If input is step input, that is x of t is equal to u of t. So in that case the response is represented as step response and is denoted as s of t. Therefore s of t will be equal to h of t star x of t is nothing but u of t. So it can be represented as s of t is equal to integration minus infinity to infinity h of tau u of t minus tau d tau. And here we know that h of t minus tau is equal to 1 for t minus tau is greater than or equal to 0, or t is greater than or equal to tau, or tau is less than or equal to t. And it is equal to 0 when t minus tau is less than 0. So therefore, considering this condition, I can represent s of t as s of t is equal to integration minus infinity to, so tau value should be less than t, so it's supposed to be t h of tau d tau. From this equation you can observe that the step response is time LTI system is running integral of impulse responses. Therefore step response of continuous time LTI system is running integral of the impulse response.